So this is the deep data track. You all know about recommendations, very personalized, very particular to your taste, and it's about things you want to buy, things you want to click on, or your next job, as in the case of LinkedIn. So let's take a quick peek under the hood. What's the algorithm that you use to get these recommendations? So usually you have a user profile, and you're trying to recommend different items to them. And you're trying to do that according to different criteria. So if you're trying to recommend a job, let's say you're looking at whether the job and the person live in the same place, whether they're in the same industry, and whether the skills match, right? So you have all of these different dimensions, and you compare the matches along those dimensions. And the question is, how do you combine all of those to come up with one score so that you can put it up on the in front of the user and get the top 3 in front of them? So there's lots of ways to combine those dimensions, and you could come up with some heuristics, and that's fine. But one of the popular approaches is machine learning. So that's where machine learning comes in. So we have hundreds and hundreds of algorithms. They're awesome. We have thousands of papers being written about playing with the priors, about inventing new cool machine learning algorithms. And that's amazing. That's pushing the boundaries of science. But there's one thing that's actually widely known, and that's that more data beats clever algorithms, right? So there's a famous talk by Pete Norwig about the unreasonable effectiveness of data, about how having more data beats clever algorithms. So one of the limitations that these algorithms have is that they're using the same data set. They're using the same training data. And that's awesome for science and for reproducibility, but it's not so great for your ROI. You're just trying to get better results, right? So we see this effect of more data being better than clever algorithms in machine translation, in recommender systems, all over the place. But more data beats clever algorithms, but what beats more data is better data. So in this talk, I'm going to talk a little bit about how to get that better data. So oh yeah, that's my license plate, the second one, more data. So I'm obviously passionate about this. And my other license plate is LSTSQR because it's a Honda Fit, so least square fit. Yeah. I know. But so yes, more data beats clever algorithms, better data beats more data. So I keep talking about this training data. Let's take a look and see how this actually looks like. Well, so in the case of the job matching example that I mentioned before, there's a tuple of a person and the job, and you have these criteria like geography and industry and skills, for example, that you're trying to match across. And then you have these labels that tell you whether that's a good match or not, right? So ideally, if you have a whole bunch of these, what you could do is train a model to tell you how important all of these different criteria are. So that's great. So where do you get this? Where do you get this training data? So that's easy because you have a user looking at this and clicking or Xing things out or not clicking at all. And you already know how to derive your values. And then the question is, how do you use this data? How do you use it to train? Well, if you just use this data, if you just use this data like that to train the model, you're in trouble, right? And that's because of presentation bias. And I know you're probably thinking now, oh, I know about that one, because People just naturally click on things that are higher up the page more than they click on things down the page, right? So we have to do a lot of clever things to get rid of that bias. And that's part of the story. Sure, you have to account for that. But there's a more subtle effect that happens, or sometimes it's really outrageous, depending on your problem. Let's say you take this data, right? But you had this algorithm that you plugged into the system that showed recommendations to the user, right? And let's say that this algorithm put a lot of weight on geographical match, right? So then all of the three things that you show the user have really high match across the geography dimension. So the labels, though, are going to be different. They're going to be ones and zeros, click, no click, right? So then your new model, what is it going to do, right? It's going to look and see that, hey, this geography business, it doesn't have any predictive value. It doesn't help me at all deciding on whether this is going to be clicked or not. So forget about it. Let's not use geography at all, right? So what happens is that you basically train the refinement on your existing model. And that gets pretty tedious if you do that every time, right? So the good news is that once you've got bitten by this, like I have, or if you see a talk about it at Strata, there's a lot of ways to get around it. So believe it or not, I made this slide in case somebody was missing the wall of text plus formula. So, but the content is real. So what you can do is explicitly model the presentation bias, right? You can use algorithms that learn from positive examples only. When you have you use the unlabeled data as negative examples, use your positive examples, you train a model, and then you retrain, relabel the unlabeled examples, and so on. You iterate on that. And in practice, when you're actually building your system for a product, what it comes down to is just choosing some random unlabeled data, which you should have a lot of on, and choose it and put it in as negative examples. And that should help you learn a classifier that's not so close to the margin. Right? So yes, that works. You have this well-oiled machine. Your algorithm is recommending things. People are clicking on it. You take the data. You overcome the presentation bias. It's all a nice virtuous cycle. Except, I overlooked a small detail. And that's, what do you do if there's no product yet? What do you do if there's no user to click on anything, right? That's the cold start problem. So what do you do in that case? You got to start somewhere. So there's several things you could do. One of them is to just show a bunch of random things to the user. And that's actually very nice because it gets rid of the presentation bias, which is great. And that's sometimes doable when you have ads or when you have news stories. But it's not so doable when you're trying to recommend jobs to people and people take it very personally and they get really, really offended, right? They say, what, you think I should be, an intern? No, you don't know me at all. I'm offended, right? So you have to be a little bit more careful. You can't just show random stuff. So in this case, you could manually set some weights, right? You can have some heuristics, set some weights, and that should work fine, right? Well, it does if you have 3 criteria, like I've shown. But what if you have 300, right? It's a little bit tougher. So what do you do? Ideally, what you want to do is have some training data. So where do you get it? Where do you get those coveted ones and zeros? Well, I know, crowdsourcing, right? Because this is awesome. We love crowdsourcing, and a lot of times when you need labeled data for machine learning, you go to Mechanical Turk, Crowdflower, SummaSource, get your labeled data fast, and you can just go ahead. And that's great. But for this particular application, for recommender systems, crowdsourcing is a little bit tricky. So if you're going to do this successfully, you have to think about a few challenges that you're going to encounter and see how you solve them. So here are the things that you have to consider. There's one, the first caveat is personalization. Because you basically have a user of your system, and you have this Mechanical Turk worker who's very well-intentioned, but they're trying to get into user's head and decide, does he want to stay in the enterprise space? Does he want to take over the family business? That one is more subtle. I don't know. Does he love data as much as we do to become an Android developer? Or maybe, I know, or maybe he just wants to switch universes completely and let the force be with him. The point is, it's hard. It's hard for that worker to put themselves in that user's shoes. And they can do it, but your data is going to be pretty noisy. So you have to think about how you overcome that. Second caveat, your task description. So if you've ever written task descriptions for crowdsourcing, you know it's pretty much like writing code, right? It has to be concise, precise. It has to explain edge cases, catch exceptions. You have to give very specific instructions. So sometimes, though, well, that's hard, right? But sometimes that's not even possible. So let's take an example of a task when you're trying to build a product that shows you similar profiles to the one that you're looking at, right? That's a product that we actually have running at LinkedIn. So you go to crowdsourcing and you ask people to rate similarity between 1 and 4. And that gets rid a little bit of the personalization issue, so which is great. And so they're going to come back to you and ask you, well, but what does it mean to be a 1? What does it mean to be a 4? I want some rules. I want some trade-offs. You have to tell me, you know, if the industry is the same, that's better than the school being the same, or working the same job is more important than this or that, right? They have very precise instructions. Well, if I had that, I would have just coded it up. I wouldn't have bothered with crowdsourcing. I don't. The reason I want to crowdsource this is because I want your subjective opinion of how similar these profiles are. But when there's no right answer, it gets really tricky to write that task description. Which brings me to the next point. And there's a whole talk here where you can talk about quality control. How do you ensure result quality, especially for a subjective task when you don't know what the right answer is? How do you decide what data to label? How do you decide how much data you need? All tough questions, and you have to overcome all of them if you want to succeed with crowdsourcing for recommender systems. And it's doable. It's not impossible, but it's pretty hard. So is there something else we can do? Is there a solution to this? There's a few alternatives. So maybe, just maybe, if you think about your data creatively, maybe there's something you can do. So I call that data recycling. Let's think about that for a minute. So the universe of data that you have access to, be it in your own company or a bunch of external data sources, it's big, it's beautiful, it's complex, and there's some signals here and there that maybe, just maybe, if you marry them with your own data, they're going to give you some signal that you can squeeze some training data out of. So that sounds pretty tough, and it's not really specific to your particular problem. So I'm just going to give you a few examples of what we've done in production systems. And for your own problem, you have to find your own solution and think about your own data sources that you can pull from to get training data. So task 1, is this profile real or fake on LinkedIn? So you could go to crowdsourcing And you can define very strict rules saying, if they have obscene last names, well, that doesn't mean much because they could actually be real people with that name. Katerina fake is not fake. You have to give all of these instructions. And then, or you could look at your data if see there's anything you can use as training data. Any ideas from people not at LinkedIn? So there's a bunch of accounts that customer service has closed over the past year, right? So hey, they closed that for a reason. There's a human labeling your data for you. So there you go. That's your positive, those are your positive examples. And random sample of the accounts in good standing, negative examples, right? So that's a lot of data that it would have been really expensive to get from crowdsourcing. But you got it for pretty much for free. So of course there's caveats about the data skew and the kinds of accounts that have been closed by customer service. And so you always have to account for data skew and have to fix those and think about how that affects your system. That happens regardless of how you get your training data. Let's take another one. This is an easy one. Trying to recommend groups to people. What training data should I use? Any ideas? This is the easy one. Yes? Exactly, yeah. So people who are already in the group. So people have already labeled themselves as positive examples by being in a group. So by using all of those, again, doing stratified sampling, taking care with the data skew, you have your positive training examples. Next one is a little bit trickier. And there's many, many solutions here. I'm not giving it all away because it's used to be one of our interview questions. I ruined that one, I guess, but retiring it in style, right? So job matching. How do you get those tuples? Yes? Yeah. So one of the suggestions was analyze how people change their jobs. So you can look at people's LinkedIn profile at some point and see their position after that and use that as training data. That's a great idea. It comes up a lot as a solution in the interviews. There's a small problem, and it has to do with how the data looks like, the data shape, right? And because one title doesn't make a job description, which is a lot more elaborate and it has a lot more different parameters. It's a great start, but not quite the shape of the training data that you want. So ideally, you want the same type of entity that looks very similar to what you're going to actually use in production for testing. So like I said, this is a little bit trickier, but let's say that you look at somebody who posted a job and then see who they contacted that same day. Noisy, but it's pretty likely that if they contacted a bunch of 10 people right after they posted the job, maybe, just maybe, those are good matches. Noisy, skewed, yes. Good free training data, oh yeah. Let's go back to our previous example on profile similarity. Again, this is tricky. How do you define similarity? Can you find any training data? Well, you could do what I just mentioned before, where you look at job posters' behavior and see that, and group people who have been contacted the same day into one group and say, oh, those are all similar within themselves. And that works okay. Or look into some other corner of your data and see that, there's this feature on LinkedIn that has folders. So people can put profiles in a folder. And if you have about 5 to 10 people in those folders, they're pretty similar to each other. Again, noisy, skewed, yes. Lots of data, definitely. So hopefully, that showed you a few methods of trying to be creative about obtaining training data. Don't assume that you don't have any, because you might have it somewhere hidden away. So why does this matter? So let's look at our old friends, the algorithms. Amazing algorithm improvements. are great. They push the boundary of science, and they're orthogonal to, well, not quite orthogonal, but close enough. They're not related. They're complementary to training data. So the Netflix prize worked on the algorithms, right? And they wanted a 10% lift or reduction in error. And it took 3 years, and I don't know how many thousands of brains to get that. This is great, right? But let's compare that to what I could get in our production systems by changing the training data. Using more data and fresher data for our system, 20% lift for our job recommendation system. Using those recycled data, a few of those recycled data techniques, 50% lift for our job recommendations. Using any kind of training data when compared to a hand-built model for a people you may know recommendation system, 100% lift, right? So these are all systems that have been in production for more than a year at the time of the change. So hopefully that kind of gives you an idea of why training data matters. So this is why it's worth spending more time on it. This is where your best bang for the buck is, in my opinion. So I started out by comparing training data with Cinderella, but now I'm thinking it's more like Harry Potter, right? Because it's on a cupboard under the stairs, and then it can grow up and do some real magic. So thanks.
So we have a few minutes here. Do we have any questions from the audience? See a hand over there.
I'm sorry?
So the question was, can you define what you mean by lift?
Yeah, you have an A/B test. You have for your production system. You have some metric that you're tracking. Maybe it's views. Maybe it's it depends on your application. Maybe it's views. Maybe it's applications that you're getting. It depends what your business values. That's specific to the business. So you get a lift in that particular metric. In this case, it was job applications.
Yep.
Oh yes, yeah. So I conveniently, so to repeat the question, it's saying, oh, it's looking to see when I'm looking at people being contacted, it's looking from the recruiter point of view to see if they're a good match for it. And yes, that's definitely true. I overlooked that because it was a nice example to show. But yes, actually, this training data, we used it for the product that showed people that are the best match for the job. So that's exactly the product that we use that for.
Yep.
So when you're bootstrapping into a bigger and bigger training set from an existing smaller set, how can you be assured in the end that you're not just sort of getting much better at basically presenting to people what they've already seen? That is, how do you break out of sort of the nominal times to actually find perhaps new streams that weren't in the training data?
Right. So getting stuck into a local maximum and minimum is could definitely be a problem in general in these kind of machine learning systems. And there's ways to get around that. There's exploitation breaks to exploration. You can always start throwing in new ideas, new features. Actually, one of the things that I haven't touched so much on was feature creation. Right? We talk a lot about feature selection, but feature creation, when you're trying to find new signals in your data that could be used as inputs, not necessarily as training data, into your system, then you add in fresh blood and new ideas, and you just put it in front of the user and you do A/B tests, right? So then that's the ultimate judge of success.
Any more questions? Okay, one more.
Oh, right.
How do you deal with skew?
How do you deal with skews? So the simple one is stratify sampling, right? So you try to, there's several ways you could go. If you have a few categories that are underrepresented, you could go heavy on them, or you might want to say, hey, I want this to be a reflection of my data and leave the distribution to match your actual data. Or you could do stratify sampling and say, hey, I have these arbitrary categories, they follow some skewed distribution, let me bring that back to a uniform distribution and put that back in.
Okay, let's all thank Monica.